Hello everyone. This video would focus on conic section, specifically on ellipse with center at HK, and this is the 8th part. In this part, we're supposed to determine the standard equation of an ellipse given the coordinates of the vertices and the eccentricity of an ellipse, and we're supposed to sketch the graph. Before we go over this example right here, let's have a review on the parts of every ellipse and the two cases of an ellipse with center at HK. Please remember that these are the parts of every ellipse. The first part is the center. For this case right here, this is not at the point of origin. Our center is at HK. This coordinate HK is the reading along the x-axis that is represented as the H, and the reading on the y-axis is represented as the K. Please remember that the center is the midpoint of the major axis. It's also the midpoint of the minor axis, and it's also the midpoint of the foci, the two foci. Another part is the major axis. The major axis is the longer diameter. This is the line segment that connects the two vertices passing through the center. So on both ends of the major axis is the vertex. A vertex is the endpoint of the major axis, and there are two of them. So we call them as vertices. Another part is the minor axis. The minor axis is a line segment that connects the two co-vertices passing through the center. So the endpoints of the minor axis is a co-vertex, and there's going to be two of them. We call them as the co-vertices. So by definition, a co-vertex is the endpoint of the minor axis. And again, there are two of them. Another part is the focus. We remember that the coordinate of the focus for this case, which is the horizontal ellipse, is represented as H plus minus C comma K. So this is the coordinate of the focus, again, for the horizontal ellipse. We remember that the distance from the center to the vertex is represented as letter A, while the distance from the center to the co-vertex is represented as letter B, and the distance from the center to the focus is represented as letter C. We also remember that the formula for a horizontal ellipse is represented as quantity x minus h squared over a squared plus quantity y minus k squared over b squared equals 1. Now, please notice that the value of a is under the quantity x minus h squared. The reason for this is because it is a horizontal ellipse. Horizontal means left and right, so the a will be under the x. Now, we also remember that the value for a is always greater than b. And the equation that relates a, b, and c is c squared equals a squared minus b squared. Now, let's look at the second case of an ellipse. The second case of an ellipse is the vertical ellipse. We pretty much have the same parts. We have the center. We also have the major axis. We have the two vertices. We also have the minor axis. We have the two co-vertices. We also have the two foci. Now we remember that the coordinate for the focus of a horizontal ellipse is h comma k plus minus c. Now we also remember that the distance from the center to the vertex is represented as letter A. The distance from the center to the co-vertex is letter B. And the distance from the center to the focus is represented as letter C. Using all these values, we remember that the formula for vertical ellipse is quantity x minus h squared over b squared plus quantity y minus k squared over a squared equals 1. Now we remember that our a squared, which is the greater value, is placed under quantity y minus k squared. The reason for that is it's because this is a vertical ellipse. We remember vertical, that means it's up or down. And so this is placed under the y. And we also remember that a is always greater than b. And the formula that relates these lengths A, B, and C is C squared equals A squared minus B squared. So these are the parts of every ellipse, and these are the two cases of every ellipse, the vertical and the horizontal ellipse. Okay, before we move forward, let's have a review on the formula for eccentricity of an ellipse. By definition, eccentricity of an ellipse refers to how flat or round the shape of the ellipse is. Mathematically, eccentricity is the ratio of the distance from the center to the foci, which we usually represent as letter C, and the distance from the center to the vertices, which we usually represent as letter A. Now, we remember that if eccentricity is equal to 0, then the conic section is a circle. On the other hand, if the eccentricity is greater than 0 or less than 1, we are able to come up with an ellipse. We also remember that if the E value is closer to 0, then the ellipse tends to be more circular in shape. On the other hand, if the E value is closer to 1, then it is more oval or elongated. Now let's look at the eccentricity formula of an ellipse. You will see the two cases of an ellipse, the horizontal and the vertical ellipse. Now we remember that the distance from the center all the way to the focus is represented as letter C, and the distance from the center to the vertex is represented as letter A. On the other hand, if we get a vertical ellipse, it's pretty much the same thing. The distance from the focus to the center is represented as letter C, and the distance from the vertex to the center is represented as letter A. Again, mathematically, eccentricity is the ratio of the distance from the center to the foci, which is represented as letter C, and the distance from the center to the vertices, represented as letter A. We can therefore write the equation of eccentricity as E is equal to C over A. So this is the formula for the eccentricity of an ellipse. Eccentricity is equal to C over A. Okay, going back to the problem right here, we are given the coordinates of the two vertices, which would be -5, 10, and -5, -4. So we're supposed to sketch these two dots here. These are, again, the vertices. So that would be on -5 and +10. So this is our first vertex. And the other vertex is on -5, -4. So this is the other vertex. Now, we remember that the center of an ellipse is the midpoint between the two vertices, or the midpoint between the two co-vertices, or the midpoint between the two foci. So in this case right here, we can determine the center or the midpoint between these 2 points, and that should be this point right here. So this is the center of this ellipse. I'm gonna label this as letter C. The other option that you can do in order that you can determine the center between the two vertices is to use the midpoint formula. You should be able to get this point right here. And so looking at this, our center is at -5, 3. And this type of ellipse is a vertical ellipse because both vertices are vertical relative to each other. So we can go ahead and label that up here. Okay, since this is a vertical ellipse, I'm going to write the formula for, or the general formula for the vertical ellipse. So that would be x minus h squared over b squared plus y minus k squared over a squared equals 1. So this is the general formula for every vertical ellipse. So in this problem that we have here, we remember that the distance from the center to the vertex is represented as letter A. So I can go ahead and write that up here. Our A is, we counted 1, 2, 3, 4, 5, 6, 7. Or you can use the distance formula for this. So that is plus minus 7. And so we can go ahead and say that our a squared is 49. So that's the number that we put in here. So this equation will come out x. We have here our center negative 5. So switch it. So this comes out plus 5 over the b squared is missing. We don't know what it is. And that is plus y. This is a positive 3. So this becomes a minus 3. Then that's squared over our a squared is 49. So I write 49 equals 1. So we are missing the b squared. In this problem, we are not given the b squared. Instead, we are given the eccentricity. Again, we remember that the formula for eccentricity is E equals C over A. So we are given the value for the eccentricity and we are given the value for A. So we plug the values in. So this comes out, our eccentricity is square root of 33 over 7. That's the eccentricity. And that is equal to C over A. And our A is 7. So I put 7 right there. So we can go ahead and cross multiply this to solve for C. So I will pair that up and pair these two up as well. So we can come up with an equation that would be 7c, that's the first part right there, equals 7 square root of 33. We wanted to solve for c, so that we divide both sides by 7, divide this by 7, so we can cross that out. So we are left with c equals square root of 33. Or this is approximately 5.74. So this is the value for C. And so remember that C is the distance from the center to the focus. So then we go ahead and count 5.74 up and 5.74 down. That's where the focus is. 1, 2, 3, 4, 5.74. So this is our first focus. And then the other focus would be 1, 2, 3, 4, 5.74. This is the other focus right there. Now, we are not done with the equation because we wanted the b squared, but we have the c, we have the a. So we can use the formula c squared equals a squared minus b squared to solve for b squared. So I'm going to go ahead and write that equation up here. We have solved for c, which is square root of 33. So I plug that in here. So square root of 33 squared equals our a squared is 49 minus b squared. Now, we can simplify this. Square root of 33 squared is just 33 equals 49 minus b squared. So I'm going to add b squared from both sides. So add b squared as well here. So we can cross the b squared out. This comes out b squared plus 33 equals 49. And then we subtract 33 from both sides minus 33. So then we are left with b squared is equal to 16. And so this tells us that our b is plus minus 4 because we have to square root the 16 and then that is plus or minus 4. So we can go ahead and write 16 down here. And so this is the equation that works for this given word problem that we have up there. Okay, so then we go ahead and say that our b is plus minus 4. This represents the co-vertex. So I go left 4, right 4. And so that would be 1, 2, 3, 4. This is the first co-vertex. And then 1, 2, 3, 4. This is the other co-vertex. And I will draw the ellipse. Okay, so then we go ahead and write the coordinates of the two co-vertices. And we are going to write the coordinates of the two foci. Since this is a vertical ellipse, we remember that the coordinate for the two foci of a vertical ellipse is h, k plus c. and h comma k minus c. So I can go ahead and write, that's vertical. So we're gonna add the c to the k. So this comes out -5. And then that's going to be 3. So I just copied everything, but I'm going to add the c here. So that's plus square root of 33. And then the other coordinate here is -5, 3 minus square root of 33. So this is the coordinate of the first focus, and this is the coordinate of the other focus. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So I'm going to plot these 2 points here that represents the 2 vertices. Now we remember that the center of an ellipse is the midpoint between these 2 vertices, or it can also be the midpoint between the 2 co-vertices, or the midpoint between the 2 foci. So in this problem right here, we can tell that the center between these 2 points is this. You can use the midpoint formula to determine the center, or you can count the distance between these two, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 divided by 2 is 6. So we count 1, 2, 3, 4, 5, 6. So that is the center. So that we can go ahead and say that our center is on 4, -3. And this is an example of a horizontal ellipse because these 2 vertices are horizontal relative to each other. So I'm going to write that information up here. Since this is an example of a horizontal ellipse, I wrote the general formula for horizontal ellipse with a squared under the x. So looking at this problem right here, we remember that the distance from the center to the vertex is letter A. So I'm going to go ahead and write that down here. So our A is 1, 2, 3, 4, 5, 6. So that's plus minus 6. This tells us that our A squared is 36. So we already have A squared right here. So we can write the equation of the ellipse now. Remember, this is our h, this is our k. So this comes out x, this is a plus 4, so it comes out minus 4 squared over our a squared is 36 plus y, this is -3, so that would become a plus 3 squared over our b is missing, so we keep that blank. However, we are given the eccentricity. Eccentricity, remember the formula for eccentricity is C over A. So we have the value for eccentricity, we have the value for A. So we plug the values in and solve for C. Okay, this tells us that the distance from the center to the focus is 4.47. So 1, 2, 3, 4.47 should be somewhere around here. That's the first focus, and the other focus would be 4.47 to the right. 1, 2, 3, 4.47. This is the other focus. So that we go ahead and determine the b squared from here using the equation c squared equals a squared minus b squared, because we already have the c, we already have the a. So I'm going to go ahead and show the work down here. So we already determined the value for b squared, which is 16. So I will plug that in here. This is over 16. And this is the equation of the ellipse for this problem that we have up there. And notice that our b is plus minus 4. This represents the co-vertex. So I'm going to go up 4, down 4, and determine the coordinates of the co-vertices. Since this is an example of a horizontal ellipse, the general notation for the two foci of a horizontal ellipse is h plus c comma k and h minus c comma k. So the coordinates of the two foci would be, that is h plus c comma k. So h plus c, so the h is 4, our c is 2 square root of 5, so plus 2 square root of 5. And then k, which is -3. So it's pretty much the same thing. I wrote the 4 and the -3, but I added the C to the H. And the other coordinate is 4 minus 2 square root of 5 -3. So these are the two coordinates of these two foci. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!